All right, welcome everybody. I think first we want to give a shout out to Melissa. Congratulations on your wedding on Saturday.
Thank you.
We wish you only happiness and great things that I know are going to come to you. So today what we're going to do is in session one, we're going to look at the alignment of instructional content with learning activities, revisit or finish up active learning in an online format. And then there'll be some information about HydroShare, connecting that with HydroLearn. And then later, when we come back at 4 Central Time, we're gonna just do a little more sharing out on the alignment with your instructional content in the content groups. So today, first, we're gonna revisit constructive alignment, then explore how the alignment of instructional content needs to be aligned with learning activities. And as I mentioned before, connecting or learning more about the active learning content, and then have an introduction to the HydroShare resources. So this is a little quiz here for y'all that Jenny set up. So if you can go to this URL, I put it here as well, so it might be easier for you to link out to, and then you can respond to your video meeting style. Hey, do you have a way to see the results?
Yes, let me share my screen and I can show you the presentation. Let's see. Watch the results come in. No pajama people, really? Someone's wearing pajamas, just admit it. There it is. There they are.
Well, I wear my workout gear. Not pajamas. Not professional either, but it wasn't an option.
It's a matter of what is professional. Which I put in the chat. I dress the same as I would normally, which is not much.
I admit I've been slacking a little bit lately. I only do the top half. Not a pajama person. Or athleisure. Pajamas and athleisure wear. How about that? Well, that was fun. Thank you for humoring me, everyone. I was genuinely curious, and I'm going to publish these results. All right, Doug. There you go.
Okay, and so once again, just high five to Melissa. Look at those pictures. How awesome is that? Wow, how cool is that? That's awesome.
We also have that Dan got married this weekend, but he was negligent in not sending us photos.
Oh, wow, I didn't know that. That's awesome.
I thought he was getting married today. He got married this weekend too.
Well, maybe it's only today. I don't know. Maybe he will. Maybe it is today, and maybe he will send us photos.
And this is something very special about HydroLearn. You know that if you are involved in HydroLearn, there's a high chance of getting married or engaged. I don't know.
You would have thought you would have done better in picking the dates for this workshop. We did have the whole summer to choose.
It's inspiring, David. So our workshop inspires people to have a change in their life. So.
Okay, so anyway, so as you know, last week you really focused on this backward design process, identifying the desired results, those big ideas, articulating those learning outcomes, and then you developed an authentic task. that learning activity that really provided an opportunity for students to demonstrate their knowledge and skill. And then you started working on planning those learning experiences, the designing of the instructional content. And as you were doing that, I know you were always iterating, going back through this alignment, making sure the learning objectives and the assessment or that learning activity were aligned, and also with the instruction. And as we found last week, it's just very much an iterative process that we need to revisit over and over again. Even a course that's been taught 10 times, I know we go back and revisit this alignment to make sure that it's all correct. So today we wanted just to zoom in a little bit on that alignment of the instructional content with the learning activity, essentially building up, making sure you're providing the experiences and the knowledge and the content that those students need to be ready to show that performance in that learning activity. So to do that, Emod's gonna share a couple of examples. You want me to just exit out of sharing, Emod, so you can share your screen?
Sure. Yeah, so I'm going to share a quick one here. I think we are all familiar now with the concept of aligning the instruction with the learning activity, and of course they are both aligned to the learning objectives. So I'm just going to show an example from, or two examples actually, and they are by no means perfect examples, but at least they are in the right direction, I think. And so this, I know the slide is busy, so this is in one of our modules, this the storm detention basin, the Beaubassin module that David showed earlier. And one of the learning activities there is dealing with developing a design hydrograph.
I'm not sure I see your screen.
Right, yes, okay. I guess it's Monday, so I assume everybody can imagine what my screen looks like. So let me see. Okay, I'm going to share the entire desktop, and you can see how cluttered my desktop is. So, okay, can you see now? Okay, so I was saying this is a learning activity that is part of a module on designing a detention basin for flash flood protection. This is the same module that David showed earlier. And the activity deals with, it's stemming from an objective that talks about how the students will be able to develop a design storm hydrograph using the alternating block method. So there's a standard procedure that people use to develop a design storm hydrograph. And the activity is basically just about that. So we want the students to use the NOAA precipitation frequency data server, the Atlas, basically, if you guys are familiar with that. This is something that they developed in the previous activity, so they are building on that. And we want them to design an event storm hydrograph. They will have to pick a return period and a duration, and then apply that method, the alternative block method, to develop, basically to convert a point value into a time series of rainfall. And in the activity, we provide them some resources. So there's a template here, an Excel spreadsheet, basically, where they can see some steps, and then they will have to complete it. There's the results template as usual of what they submit. And I also have a video tutorial for them there. So the content, and I guess that's the point that Doug wanted me to talk about, what content I had to develop to support them doing that learning activity. So this is the section in my module outline that talks about so I developed this hoping that it will teach them how to do that learning activity. So there's a little bit of background on what design storms are. I also provide an example on the alternating block method. I also provided a video. And then before I send them the learning activity, I had to check your understanding. So very quickly, I'll show you what that looks like on HydroLearn. This is the studio, so maybe I can just look at it in the live view. Can you still see my screen? So this is what the students see. So background here, I had to kind of help them understand what a design storm is. So a few definitions, a little bit background about how to develop hydrographs, some graphics here, some visuals on what a hydrograph will look like at the end. presented in different ways. I picked those two storms from the area, the same area that they are working on. This way they have some familiarity, or at least they can relate to it. Discuss, how you can present a rainfall storm. Pretty basic information, but sometimes the students, struggle with that. And then I get into teaching or at least going over the alternative block method, block design storm. There's a little bit of graphic here that shows how that works, and I give credit here actually to Madeline Merck. She's a student of David Tarban, who actually developed a lot of that material in the first version of the Dry Canyon, which we adapted here. So this is also a good example where we built on what they already did, and I believe we were able to improve in a good sense, on and add and make it richer actually. So, and then I close here by just a summary steps for how to implement that. And then the next section, there's a simple example, right? Because the one that they are working on in the module is pretty involved in terms of the basin and the storm and the watershed. So, but this is more of an idealized one, almost like a textbook example, but I thought it's helpful to them to see the steps, step by step, with the data on a simple example and what their outcome should look like at the end. And then I also have them, I embedded here a video on, again, this is something that Madeline developed. You can almost hear her voice there.
Video demonstrates the use of
So this was a great thing, videos are always, the students like them a lot, so this is really the, and a lot of that actually, to be honest with you, I developed this as part of my, I taught the class last semester, so I'm gonna convert this or have a video also with that simple example. The students like the videos a lot, especially if they are short and sweet and they can replay them again and again, especially if they have the content here. I'm also thinking to put a spreadsheet along with this simple example for them to see the calculation. That also can help. So things like that can actually go a long way with the students and make their life easy. So that's the content that I had for this activity. It can definitely be enhanced, but at least I have some background information that explains the theory or definitions. I have some graphics that talk about what that really means. And then I had an example on how to implement the method with some video tutorial on how it can be done. Another example that I want to show you also is from a different module. This is a module on energy water. So those of you who are interested in this topic in general, they can actually check out this module. We have it on HydroLearn. It's a pretty long one, but this is an activity, right? And the activity in that module, this module talks about energy and water in general, focusing more on water needed for energy operations. So the activity here, I wanted them to analyze water requirements for energy generation. And the specific activity is to analyze the impact of different power plant configurations on water consumption by thermoelectric power generation sector. And I wanted them to look at different configurations of power plants when you do go through a retrofitting. Again, this is a kind of a real world example where you can change the cooling type or power plant technology, or you can also install a carbon capture and sequestration unit and quantify how these operations or these different options will impact water requirements or water consumption for power generation. So this was the learning activity. Now I needed to make sure that they have the instruction that would help them do that. Actually, they implement this learning activity with a lot of data. So this is data intensive activity where I provide them with a real power plant, real data on the configuration and the water requirements. And then I ask them to calculate changes in water requirements in response to these different technologies. But then I had to build quite a bit of background actually to help them understand these concepts, So we have a good section here on what is thermal energy generation in general. So that goes through the different fuel types, different different fuel types and all this background here, renewable energy. So a good background. It's very text-based here, which is something I need to work on. It has a lot of graphics, which is good, but I think it's a little bit too much text. But anyways, they have the information here, the tabular summary of the cooling systems, types of power plant technology. So it's a good, summary here of all that. And then I had to take them into another also instruction content there that talks about, again, how do you quantify the water requirements for power plants, with different configurations. And so there's a lot of graphics here that talk about that, and basically built the background that they needed to be able to do the learning activity, which comes right after that. So this is the learning activity. Like I said, it's map based, so it's a nice activity. But the background for this one, or at least the instructional content, was pretty extensive to be able to build that knowledge, given that it's not really necessarily the most traditional content that we teach in our classes. So yeah, so anyways, like I said, this is by no means a perfect example, but at least it gives you an idea about how the depth of information that you need to have in the instruction content that prepares the students to do the learning activity. I'll stop here and see if you guys have any questions for me or.
So Ahmad, I asked a question on chat about how do you attach a spreadsheet in HydroLearn, and can students see separate worksheets in the spreadsheet?
So, and I think, I don't know if Jenny has a part of the presentation on that. It's very simple, as long as you want to make it simple. If you want to have some more advanced, so simple mean I can just provide a link to the spreadsheet and they can download it basically.
Okay.
So as simple as that, so I think I have an example here, and it's very simple because, I'm sorry if I'm going back and forth, but I can come here, let's say I'm in studio now, right? And sorry, Jenny, if I'm going off tangent here or Doug, but I can come here and say, I guess, there's a way you can actually insert a link, not through this one. We'll have it as part of the technology, but there's a very simple way to do it, actually. You basically have to upload, you see here.
You have to go to the files and upload.
Upload, browse your computer, then find where your spreadsheet is, put it there, and then once it's there, right, you can have a link to it. Copy the link, right, and use that link URL into your own module. It's just as simple as that. Now, that doesn't mean that they interact with a spreadsheet inside HydroLearn. They just basically download it, which is perfectly fine.
Okay.
Yes.
Thank you.
No problem.
Thanks. Imad, Christine is asking, what level did you assume the students were at, and how many levels up is this activity?
What level did you assume the students start at? How many levels up in level? You mean like their prerequisite knowledge, or what? What do you mean by level, Christina?
Booms, technosonomy.
I'm sorry?
Christina answer.
So the levels, like level 1, you're asking them to remember something. Level 4, I think, is evaluate. 6 is create something. Right.
This activity, actually, the one I shared, especially with the alternating block method, that was apply. So it covers, I think, some of the understanding, because they have to know the terms, and they also know how to apply the method. In the case of the energy one that I showed, I actually had to, it went all the way up to analyze, because they had to change the configuration of the power plant, recalculate things, and compare and project water use depending on different future scenarios. So it was a little bit more involved than just the application. Okay, there's a lot of time talking about power plants and their configuration. There appears little connection with learning. Right, these were two separate activities. Willie, I'm sorry if I confused you. These were two separate activities altogether. These were two examples. So I'm not sure if that's what you were confused about. You thought that these are connected? Yeah, these were two different activities altogether. One that is part of a module on flood protection, and the other one is part of a module on energy water nexus issues.
Okay, I didn't realize there were two different modules you were talking about.
I'm sorry, yes.
Figure those things out.
Yeah, no problem. That means I confused you, so I'm sorry about that. Yeah, yeah. There's those of you who are interested in war, energy, and Nexus stuff. We have 2 modules that are pretty extensive in that subject, and I would love for you to look at it. And if you have interest, you can basically get a copy of it and modify it the way you want. You know. And I should also say that, you know, this process really is, you know, there's always a continuous improvement. So there's no way that you can get the content right from the very first time. So don't be intimidated by, oh, this is too much, or, you know, I don't have time, or, you know, whether for the workshop or later. As long as you have the skeleton, I think, with some good ideas, you can always improve. You can always improve. You'll always add content. When you teach it the first time, you say, man, okay, well, I realize right now there is a gap, you know, in my content there, or I developed something neat in my class I can just bring to HydroLearn. So you'll always add to it, you know, so it's okay, you know, to have that continuous improvement as part of the process. Doug, I'm gonna stop here so that I don't take too much of the agenda.
Thanks, Imad. Those are great examples. Okay, so for the next thing, we wanted to just drop you into your partner groups just for a short time, just for about 10 minutes, to really think about that alignment between the instructional content and the learning activities that you've been developing. So in your groups, you're just gonna pick one instructional content / learning activity to talk about, review the objectives and the activity, but then really try to think about where your gaps are in your alignment with the instructional content and the learning activity. So just keep in mind that, you know, the instructional content really should help get them ready to do that performance in the learning activity, and how might you strengthen that instructional experiences so the students can perform better on those learning activities. So I think Jenny's going to drop you into your groups, and then we'll come back here just for a few more things, including HydroShare and some other HydroLearn content after this short 10-minute collaboration.
Okay, so over the break, Melissa, Jenny and I had a bit of a discussion over Hillary's question. So Hillary put a question in the chat: are all activities aimed at students on their own rather than faculty teaching the class? And if it's for faculty, would slide decks be more useful than text instruction? So we think that slide decks can certainly be part of the instruction material, but you've been seeing a lot the diagram that's talking about alignment between objectives, instructional content, and activities, and we're trying to effectively use HydroLearn to promote the sort of complete active learning pedagogical package. So I think thinking about activities, thinking about active learning is what we've been trying to do at one level, and sometimes slides fall short of that. So I think it's certainly valid to include slides in your modules, but we want to have activities as well. But there's another aspect to it. I think what we're trying to do is promote collaboration and sharing of learning content between faculty, and that's where slides can actually help. I remember the MOCA effort from years back that Thorsten Wagner and some other folks promoted, where there was sharing of slides, and we want HydroLearn to be a place where faculty can see how other faculty teach classes and maybe benefit from that, how other faculty teach classes with active learning, problem-based activities, and also maybe use other faculty's slides if they're included. So I see slides as part of the instructional content, but not the whole thing.
Thanks, Dave. Yeah, I guess the question came from a place of having reused quite a lot of the content from Sir Colton site, and that's one of the things I find really useful in that site is that I'm using one of their activities, but then they have some slides that enable me to introduce it to the class before the students get going on the activity. And I wouldn't necessarily use a bunch of text to give to the students, but I would use just like 5 or 10 slides to tell them like, okay, here is an intro to the case study, and these are the kind of techniques that you're going to be practicing in this activity.
Right, so I think that the slides that go alongside as one of the things that you can download with each section of the module that an instructor could use in a lecture would be a good thing.
Thanks.
Thanks, Dave. So I think now we're going to turn it over to Laura and Jenny to share out a little bit about more of the HydroLearn functionality.
Sure, I'm going to share my screen now. And some of you may have begun putting some of these things into your modules, but I'm just going to go through the mechanics of a couple of things in HydroLearn. And I'm going to start with the check your understanding activities and quizzes and how to put those into your modules if you haven't done so yet. And so I'm going to kind of walk through using my studio. So you'll just navigate to the place in your module that you would like to have this quiz, and then you can go to problem here. And also for all the things I'm going to show you, HydroLearn 101 is a great resource if you need to go back and refer to find some of these things as well. So you'll go to problem and you can insert a quiz type. And so I'm just going to, for example, click multiple choice. And so it'll drop the quiz in here, and you can go to edit here, and then you'll go to advanced editor. And this is what the source code will look like. And so the entire quiz needs to be enclosed in problem and problem. And whenever you type your response here, you'll have a lot of options to put different text, but not all of it is necessary. So if you don't want as much, wording, you can just delete the parts that you don't want. If you make an error in this, it'll immediately pop up red. And so whenever something turns red, you'll know that the last edit that you made was the source of your problem. And so then you can go back and make an adjustment. And you can see here, I've just deleted some of the text to clear things up. You can make it as wordy as you'd like. And then if you want to make an entire quiz with several different answer or question types, you can do that too and keep it in the same component. What I like to do is go and find the other type. Maybe I want check boxes, and I'll just create another component, and then you can actually go into that advanced editor again and just copy what you would like. And I'll just copy that, and then you can keep everything in one component so that you can move it around your module however you would like. And you can edit this one and just enter and paste it in, save it. And then you can see you can have several different problem types within the same quiz. And so that should keep things there. And then again, you can go to HydroLearn 101 in the slide. There is a link here, and it'll bring you to different easy access codes for the problems and quizzes there. And so the next thing I'm going to show you is inserting. Oh, yeah.
Before you move on, Willie asked a question in the chat box. If you could go over briefly go over the different types of problems and their features.
Okay, sure. I'm sorry, I can't really see the chat box on my screen. I'm not sure how to see it. Can you read them out if you find some?
Yeah, girl, I got you.
Okay, so some of the problem types here, we have check boxes, drop down, multiple choice. They have several here. For example, the check boxes allow you to put more than one correct answer for the student to access. For example, when you edit here, you can see that there are 2 true answers. So that the student has the option to select several correct answers. Multiple choice, you have some with hints and feedback. So then you can put in your hints and feedback for the students as they navigate through the quiz, and they can have some, response from you as well. Text input, I'll go to the HydroLearn 101. And in this module, you can see that they have the example problem codes you can download there. And then they have all of the different problems and what they look like. For example, numerical input. They can type in the number, the value, and you can make it as precise as you would like there as well. So several options to make a very big quiz, and you can move it around within your module however you need to. They have advanced problem types as well, which would be like drag and drop, open response assessment, and several options there too. For inserting images, this is important too. I'm going to mention it later, but especially we were talking last week about iPhone accessibility or other devices. So whenever you insert an image, it is important that you hyperlink it so that depending on what device a student is using, the image might not display correctly, might be distorted. So this is how we recommend that you do it, is you create images in a new component, and that way you can organize your text around that image. So you'll put a piece of text, you'll insert an image, and then continue with your text, and then you can move your text, your image wherever you'd like in your module. But we recommend that you use the HTML text editor, and then you can insert an image by using this button here, insert or edit image. And so what I like to do is go to my content manager and the files and uploads and put the images that I'd like to use there. And you can drag and drop them from your computer and name them here. So I'm going to go back to my outline and walk through that process. So I'll go to my text editor. I'll insert the image. I'll collect it here. And then I'll give the image a description. And this is important because those who are using or are visually impaired or need to use a screen reader, this will give them that image description at that point. And then you can insert the image. If you change the dimensions, you can do that as well to get the size right. And so you can put your image here. You can, give it a label there as well and save it here. And then the important part, as I mentioned, is the hyperlinking this image. So you'll go to your content manager, you'll copy that link here, and then you'll go back to your image and make sure it's linked. So you go.
So I had a question that I sort of struggle with, and maybe others do, with respect to these images. You have the opportunity to write text that's alternative text for sort of people with disabilities. How do you actually write text that explains an image? I mean, it's really hard, and I don't know if anybody has any comments on that.
Right. Oftentimes in our modules, we'll number the images first of all, so that as you're typing your text, for example, in your background material, and you refer to figure 1, whenever the student looks at the image, it'll also say figure 1. So that's one way to make sure that the image is correlated with your text. And then an image description can be lengthy or it can be short. For example, this image, I believe, I have it labeled, I can even look. It's the difference between water depth and water level. So I guess that's at user discretion, but certainly the alternative text might need to be more lengthy than what the student sees within the module. Because here you can, this could be example 1, And then whenever they read in the text, they'll be able to connect those images, because you may have several images in one subsection of your module as well. And then when you hyperlink it, you highlight the image, it should turn blue. And then you go to Insert, Edit Link, and then I can paste my link there. And when I target, you select New Window. So that way when the student clicks it, it'll open it in a new tab. They won't lose their spot in HydroLearn. And you can save it there. And this helps especially on other devices, because sometimes the image could be distorted there. And then if you need to move your image around, you can just drag and reorder above or below a quiz, you know, anywhere within your text, and it should be there. The next thing is equation. Oh, sorry.
Can you resize the images?
Yes, so whenever you go to edit, you can go to the HTML source code here, and you can change the height and the width here within the figure. You can also change its, you know, alignment with these alignment tools to move it left or right of the screen.
Hey, sorry, I missed it. Where do you put the alternative text in here?
So that is whenever you insert the image, insert edit image, and you click your image that's in your content manager. When you hit next, it gives you an option for image description here, and it's called alternative text.
Okay,
and
thanks.
This is where you'll type in your image description for those that need a visual aid. But this label below the image can be different, or it can be the same. You can make that as well. And then I'll go to equations. So I do have some equations you can see here. This is how they look in HydroLearn. And the equations, you can use HTML text box, or you can use the advanced text box. The main difference there is that the size of the equation will be different. So you can play with that and see what it will look like. I'll show you here in the slides. For example, in HTML text, the size of your equation may be a little larger, but it'll do the same thing. It'll do the same thing. So I'll go to edit here. And then when you type in your equation, it uses LA text. So again, HydroLearn 101 has a lot of different equations and examples, but I'm going to highlight this example equation and copy it in. And so it looks like this within the editor, but then as soon as you hit save, you'll see it in your module as it should be. If you make a mistake and there's something wrong with your formula, for example, if you don't close the problem properly and then save it, you'll immediately know, because it won't show up as an equation. It'll still show up as the LA text code. So that's how you'll know you made a mistake, and you can go back in and edit it and close it there. And you can type equations on their own lines independent. For example, this equation here is by itself on its own line, but you can also type equations within a line of text, and it's a matter of opening and closing the equation in a different way. So this one is closed with brackets. If you wanted to type an inline equation, you would use parentheses instead of brackets to open and close the equation. But several examples, again, are in the HydroLearn 101, and so that's super helpful as you're typing in equations for your modules. And also mobile view. So if you need to check your settings. And so this would be Studio, in your HydroLearn Studio, you would go to settings at the top. You would click on advanced settings, and you just need to verify that your course that you're building, your module, is accessible to those using other devices. So in IMS, you would go to mobile course available and make sure that it says true. And so this allows someone to go on their iPhone or their Android phone or any other device and view your module and the material there. Some of the things, I think the only thing we've noticed that is sometimes different is the images, but as long as you hyperlink it, they can open it in a new tab and see it as it should be. So just reminder to hyperlink those images, and then all of your other course material should be visible on that other device. So I think that's all I have. Are there any other questions?
Hi, Laura. So on your last, so on this page of the slides of the mobile view, so we changed the value from false to true. What's the implication? Does it adjust the format of the web page to fit the mobile view, or just say, okay, I allow mobile user to see it regardless of how messy the format might be?
I believe it allows it to be visible on mobile devices, correct, Jenny? Is that right?
Yes, it changes the width of the text boxes, the width of images, and it makes everything look really clean and polished on a mobile phone. Laura and I tested it. She has an iPhone, I have an Android, and we were checking, you know, hyperlinks, the images, the equations,
The iframes work. Yeah, the iframes look good.
Yeah.
Okay, I see. Thanks. So it serves both goals. So enable the mobile view and make it neat. Thank you.
Mm-hmm.
That's great.
We have one question in the chat from David Chandler. Is it possible to have an arrow move around on the figure in one instance of the figure? And I might need some clarification on that, but that sounds like a screen capture sort of thing, which is more of a video and less of an image. Is that what you're referencing, David?
Yes, I guess that's what it would be, is to identify various segments of the figure by moving an arrow. So I'm not sure if that would be a sequence of pretty much similar figures with an arrow that would move, that would show up in different parts of the figure.
That sounds like Screencast would solve that problem. I'm not super familiar with things you can use to capture your screen, and you could definitely use your mouse to move around, but we can look into that some more.
I think you can also do it in PowerPoint, and you can have a part of the image that moves around on a set track. I've seen that used quite nicely before.
Thank you.
Is that saved as like a video file, Hillary?
I think it's like a transition, maybe in PowerPoint. I'm not quite sure what it's saved. I think it's just saved as a regular PowerPoint.
Check that out. Thank you for that. We have another question from Gianna. Can you copy and paste your equation from a Word document? If you want your equation to render the way that, like Laura showed you, you should use LA text. But you can also, you know, take a shortcut and insert an image of the equation. But we recommend actually taking the time to do LA text.
Oh, I guess what I meant was, could you access that code inside of Word and then paste it into the HTML, like the code that, you know, if you're already real familiar with developing your equation there, can you access that code for that equation and then put it into the HTML?
Do you mean that you would be writing LaTeX in Word and then copying and pasting over?
Using the equation editor in Word.
No, it has to be LaTeX. You can't copy and paste the equation editor from Word. Yeah.
That answers it. Thank you.
Sure. Can text be written to the right or left of an image as in a text box? You can do that with the image indentation. That does the text wrapping around the image. Oh, Damien recommends OBS for screen capture. Thank you. Let's see. And then Christina provided some really good resources about having descriptive text for science content. So adding descriptive text to our images to help those who are visually impaired. Wow, guys, that's a lot. Do you have any more questions for us before we move on? Y'all are really testing us here.
Oh, Jenny, well, my question was about how much description can we put into HydroLearn? So when you were putting that in there, you had like a long description and maybe a short text, and I was surprised how much description was considered a best practice, because I had never really looked into this before.
There is no text or character limit to the alternative text input.
Okay. So
you could write a novel if you wanted.
So the last link I put in there, I guess what I was wondering is, in the case of a line graph, so I just sort of dove into the details of, like, for an example of like what's the best practice for putting a line graph as an image, and it says you should like describe the whole thing in way more detail than I expected. Yeah. Is that if we were going to go that do that, would we put it in as alternative text? Because I feel like alternative text is the short version, and I wasn't sure.
I think alternative text is where you should put that, because if someone is using a screen reader, that's what's going to pop up.
Okay. That's helpful. That was my question.
Okay.
And the alternative text won't show up if someone's not reading a screen reader, using a screen reader, or some kind of Braille converter. So for people who have no issues with vision or sight, they can just read the graph. For people who aren't able to see it, the screen reader will then read them the description of the graph. So that will give them an understanding of what that figure is showing.
Okay, thanks.
All right, so thank you, Laura, for your demonstrations. I'm going to cover the Google My Maps. We use My Maps to give geospatial reference to our modules. It's easy to use, it's easy to embed, and it's a stable resource. So we recommend Google My Maps, but that's not to say that you can't use other things, preferably open sourced, of course, maybe like Google Earth Online or whatever that may be. So I'm just going to go over quickly a Google My Maps example. We have My Maps here in Bovasin module. Let's see. We have it here embedded as a page, so that's the tab that the students can frequently reference, no matter where they are in the module. And we also have them embedded within a unit itself. So if we have some text, say, about the study site, we can also just use an iframe tool to include an interactive map within that same page. I'll show you what that looks like. You can, we like Google My Maps because you can upload KML files to create the different layers that you may need. So in this one, we show like watershed boundaries. You can zoom in and out. You can click on the outlets. Some information is showing up here. You can click on the streams. And in order to do this, you can go to google.com/maps, and you're led to a screen that shows the maps in your collection. So this is what I do. It'll show the maps in your collection, and then to edit one, you just click on that picture of it. If you want to add you can of course add layers just by tracing in here in Google My Maps, but you also have an option to add KML layers. If you want to do that, you just click Add Layer. You go to the untitled layer that's just added and click Import. You can upload CSVs, Excels, KML, or GPX files from your computer. You can also, associate images with certain points, which is useful for those of you who are showing a local watershed. It would be useful for you to include pictures from the site for those of us who, can't go access to site. If you want to show a particular feature. And in order to embed a Google map, you click the 3 vertical dots at the top right next to the title, and you're going to click embed on my site. This provides a complete iframe code. So you would copy this whole thing and then put this in the iframe tool. You can delete everything that already exists in our tool and then just paste this. And you'll have a functioning map that students can interact with. And of course, you can change the width and height here within that code. Do you have questions about my maps to load a GeoTIFF? I'm not sure, unless that's GML, then yes, but I suppose maps can be somewhat limited in what you can load. Oh, okay, so Courtney kind of answered Manuela's question. So it seems that you can load that GeoTIFF file to HydroShare for sharing with your students. You can also, there's no limitation in HydroLearn's content management, the files and uploads. If you would like to share files like that with your students, you can just upload that file and then copy the studio link and then hyperlink that in a resource table for your students. We went over those instructions on day 3. Slide 13 is about linking documents. And of course, map files fall under that. I know I've shared some files like that in modules I've created before. Something else that people have questions about is how to link another portion of your module. So let's say that your students are in a specific unit and you want to redirect them maybe to another unit or to the overall learning objectives page. The directions for how to do that are on the right-hand side of every unit page. And every unit page has a unique location ID like this. So if you want to link another unit that's within your module, you would use this jump to ID trick. This has to be put into an HTML component. And you'll have to copy the location ID of the place you want to redirect your students to. I'll give you an example of how I did this in my module template. So here, all I did was I added an HTML text component. I already have the location ID of the place I want to go to, but this is the location of the page that I'm on. All I did was I copied this link from the page I want to direct my students to. This is the ID that you need. It's already provided that here just for a quick reference. And when you create the hyperlink, you use /jump _ to _ ID / and paste this ID exactly as you see it. On the example on the side, it has the greater than and less than symbols. You don't need to put the location ID within those symbols. You actually get rid of them in order for it to work. So let me see if I can show you my hyperlink here. Yep, see here it is / jump to ID / and then that that specific location ID. And so when you want to redirect a student, they would just click that. Oh, of course. Gotta love live demos. This was working on Friday. I promise you. I see you laughing, Dave. So when we regroup this evening, I'll show you one that works. That's embarrassing. But that's the idea when that works. So I'll revisit that this afternoon. Do you have any questions for me about, embedding maps or linking to another location in your module? All right, Dave, you have the floor.
Okay, if you could, I'll share my screen. Let's see. So you should be seeing my screen. And last week, we got the question actually from Joe that said, is it possible to set up a system for students doing a module in HydroLearn to run Python code directly from an online console without installing Python on their own computer? If so, how can data be accessed by the script? So that got me into exploring some of the functionality that we've got. There's Google Colab, which is a general purpose collaboration system supported by Google. There's HydroShare, which I work on, and that's for the quasi community. So I started putting together slides about this, and this is a little bit of an interesting story because it kind of links back to the slides, the discussion with slides and Hillary earlier, because I decided to, rather than giving you the information in slides, to effectively present a HydroLearn module, sort of practice what you preach. I see Jenny said, can she interrupt real quick? She's got it working. So I'll break out of that and let Jenny interrupt. Go ahead.
Sorry, Dave. Let me share my, can you stop sharing real quick, Dave, so I can share my screen? All right. So apparently you need to put it in live view before you click that link. That's all that I needed to do. So from here, if I just click it right here, obviously it will say page not found as we experienced. If I click the live view, and when the page loads, you can go to the hyperlink and click it, and it works. Any minute now, it will work. Aha, I told you. So there we go, guys. You got to view live, and then click the link. Dave, you can now resume.
Okay, so the long and the short of it in terms of practice what you preach is, over the weekend I put together this very short HydroLearn module on embedding data and Python code into a module. I've got a couple of slides on it, but I might as well just show it to you. So here's my browser. You can scroll down. There's the little module. So giving a problem statement, is it possible to set up a system for students to run code directly, and then covering how to do it in Google Colab and HydroShare, pointing out what the objectives are, and that the audience is instructors developing HydroLearn content, but it may be of use to others, and that you need some sort of Google account as well as a HydroShare account. So if we go into viewing the course, the summary content, and I'll just skip over it fairly quickly, is fairly similar. The learning objectives is that you should be able to execute code for simple data analysis using Python and Google Colab, and execute code for simple data analysis using HydroShare Jupyter Hub. I should have also put there, and know how to build it into a module. So the next one, the next part of it gets you into the what I'm calling flow from Snow in Google Colab. It's illustrates using what's referred to as a Jupyter notebook containing Python code saved in Google Colab. And it's going to need some data to work with. So here I actually put the data in HydroLearn, and we're going to use a USGS text file as well as some Python code. So these are saved as files in HydroLearn, as we've seen earlier. So you can actually click on them, and I'm going to just save the page on my desktop as a text file, and I'm going to switch back here. If I click on this one, it's now showing me a little bit of Python code that I wrote. So this is also illustrating how you may be able to share with your students some code that can be used. And I'm going to also save that as a file on my desktop. It's file named getDataFunctions.py. So I may be interested in going to my desktop and seeing that they actually came across more or less correctly. So there is the USGS Streamflow data. So this is data you just download from the USGS for a particular location, the Logan River, and then the getDataFunctions.py function. I could also edit it, and let me just edit with the notepad, and you can see the Python text there. So checking that we got the data correctly. So then I'm going to open Colab. So this was a Colab X block that I built into HydroLearn, and the text down below explains how to do that. That came out of one of the modules in HydroLearn 101. But basically, it says you just put this Colab.x block in your advanced module list, and then you have the capability to add a link like this with text that says you're going to use it, and it's going to prompt you to sign into a Google account, and you may receive a warning that you're executing somebody else's code, so sort of to be careful with it. So let me click on that. It's showing me there that I'm already logged into a Google account, and it is showing me what is a Jupyter notebook running at colab.research.google.com. And here's the explanatory text about this. And then it's showing a little bit of code here to load a USGS Streamflow file into the system. So the Google Colab site that I opened doesn't have the data yet. So I'm going to just run the cell by clicking on that. It's telling me that it's not authored by Google. Be careful. I happen to trust this guy. You guys may not. Now I get an opportunity to browse for that file. I look on the desktop, find that one that I downloaded, and now that file is uploaded. So this is one way you could provide data for your students to work with. The next cell is to upload the code. So I'll browse there. I'll select that. So now I've actually uploaded data as well as some Python code that I provided. One of the challenging issues working with Python is you have to worry about all of the libraries that you use. And this little bit of code that I wrote, I used NumPy, the numerical Python library, Matplotlib, and Pandas, which deals with data frames. If you're working on a system that does not have that installed, you might need to install it, which is what that's reminding me there. In the Google Colab, that seems to be there already, and I just discovered that experimentally by trying it out and finding that it worked. So I can run this just to effectively reference those things. So now that snippet of code is run, now this is the stuff that's going to do some work. It's actually going to read this file that I import and make a plot. It's also going to use the other function that I had in that code to read data from a Snowtail site and make a plot. So so in this case, I buried the data access details from the students. They can certainly go and see the Python code that's involved, but we're wanting them to focus on the sort of hydrological substance, perhaps. So you're looking at a streamflow record and a snow water equivalent record, and maybe you want to do a simple analysis that says pick out the peak streamflow and pick out the peak snow and see if they're related. So there I wrote a little bit of Python code to select on a year's data, pick the maximum and plot the one versus the other, and then use a fitting regression equation, a first order polynomial, which is a straight line, and plot that. So there you end up with so on the x-axis you've got snow water equivalent, and the y-axis you've got discharge, and you've it's printed out what the equation involved is. The maximum daily stream flow is equal to that quantity plus the slope times the maximum snow water equivalent, and that was what I sort of embedded in here. So this is one way that you could distribute code and data for students to use in HydroLearn, taking advantage of what Google has provided with the collaboratory. Any questions at this stage? So this then just explained that. The next part was effectively doing the same thing with HydroShare. So to be able to do that, you need to have a HydroShare account, and you need to be a member of one of the groups that can support computation in HydroShare, and there's a bit of explanation of that. The activity is to open this resource in HydroShare and run it on one of the HydroShare compute platforms. So let me do that. So this is a resource that I added to HydroShare. I made it public, so you guys should all be able to access it. And you can see it's got similar content. It's got the flow from snow Jupyter notebook file. It's got the get data functions. Let me switch into a listing view so you can see the full file names. It's got a README file that actually renders down below. And it's got the data. So it's combining code and data here. I'm going to open this with the Quasi Jupyter Hub platform that is supported by Quasi. This code will also work on CyberJS Jupyter for Water. And I get given a choice of server options to use. I can go with the minimal option. In that case, I'd have to go through installing those libraries. Or if I go with the scientific option, they happen to be there. That I just, well, like you can read here, pandas, matplotlib, and various other libraries are there. So if I start that, so what it's now doing is copying the data from the HydroShare data storage into the compute platform, which is jupyterhub.quasi.org, which is what Quasi is supporting actually in the Google Cloud. It takes a while because it's actually creating a new server for me with that software and setting it up. If I had been I guess it's remembered that I've logged in previously. Often it would ask, prompt me to log in, and the first time you guys do it, it'll prompt you to log in and authorize. But my browser remembers that I've been there before in its cookies. Rather than watch this go on, let me switch back to the slides, and I'll just give. So we talked about the HydroLearn Embed Code 101. This shows the Google Collaboratory where you can read about it, and the little Python code, or the flow from Snow Python notebook that I wrote. So just to tell you what HydroShare is in case you didn't know, it's a community platform supporting water resources research, operated by Quasi with ongoing development through a collaborative project that I lead here at Utah State and involving these other universities. And if your module requires data, consider using it. So the key concepts are that data and models are first-class objects. They become social objects that people share, perhaps collaborate around, and they're stored in what are called resources. It's helpful for research data management, and you should really use that at the beginning of your project throughout the full life cycle. And it can include things like geographic rasters, which we just had a question about, as well as multidimensional data, shapefiles, time series, and many things. There's really two parts to it. The first is the storage, which you interact with on the HydroShare website. And when I was showing you the resource landing page, I was interacting with that. Then there's also the compute part, where there's a number of web apps that can act on the content of the data to provide immediate useful value. And we were using JupyterHub there. And there's a few others that are shown there. So in terms of storage, you get things like the website here with a landing page that describes each resource, helping you manage your data, share data and models and research projects. You can get a digital object identifier and fulfill findable, accessible, interoperable, and reusable open data mandates. And for compute, effectively it provides a web-based gateway to computing that allows you to do things that you may not be easily able to do on your PC, which was the original question that we started with. How can students using a module do some work without having to install Python on their computer, without having to worry about whether their computer is sufficiently powerful or compatibility issues? It can help you with model input data preparation and model execution, with whatever you do in that in a compute environment. So those are some of the things you can do there. So this was the JupyterHub connected to HydroShare, the flow from Snow Jupyter Notebook that I showed you, and you can run it on either Quasi JupyterHub or the CyberJS JupyterHub for water. The differences between those is this is run in the Google Cloud, and this is actually run on the NSF Exceed facility. And there are a few summary of the high points about HydroShare, and I would encourage you to use that. Let me go back and see if we got any luck here. Okay, so you can see now my browser has opened up this Jupyter Notebook. It's showing me the files that I had. It's showing me the flow from Snow Jupyter Notebook, the getDataFunctions.python file that was in the notebook, the README file, the text file I got. And unfortunately, there's this one that was left over from yesterday that I should have deleted before I did the demo, because that's that didn't just come from the HydroShare resource. You can see all of these came a couple of minutes ago, and it was a day old. So I can actually open that, and now you will see it's running the Jupyter Notebook, eventually maybe. and it's it's very similar code to what we had in the Google Colab, except we didn't have the two little cells to upload the data. It's just doing the libraries, running the functions to get the data, and running the function to do the analysis. So I can click on this little symbol to execute that compute cell, and it does the computation of importing those libraries. I can go, and there's actually a shortcut, Control Enter, that's very convenient for doing these executes, so you don't have to click on the button. That will execute the functions in this library and eventually produce those same plots that we saw previously, and do the same one on the last cell to see my results. So let's go back to yeah, I believe that was all I wanted to show. Any questions about any of that?
Thank you, Dave. That was really helpful. That really answered my question. I was wondering, for the Google Colab, can you do a number of different coding languages in that, or is it specific to Python?
I think you can do. I'm pretty sure you can do R as well, and you can on the HydroShare or Quasi Jupyter Hub you can use R. Jupyter Notebooks supports Python, or which are languages that I know, Julia, which is another language, and that's where the J comes from, and perhaps some others. I don't. The only ones that I know that Jupyter supports are, or the only languages I have any ability to code in is Python and R. I do not think it does the sort of older compiled languages like Fortran or C.
Okay, great, thanks.
Just a, David, here in Harmon here, just a question on that. If we have our own Python package, it seems like there's sort of three options. One would be that we could get, we could have the students install it either by having the code available as part of the HydroShare, and so they'd have to do their own, Python setup.py install. The second would be that it's pre-installed somehow on Jupyter Hub and provided as part of the environment. Or a third would be something like making it a Conda package that they could download just with a command like, Conda install whatever. So the particular package that I've got has a bit of Fortran code at the heart of it that needs to be compiled. Do you have an idea about what might be the easiest approach there, or is this a better question for the Quasi Jupyter Hub people?
Well, so I'll tell you what I know. It's probably a better question for some of the Quasi Jupyter Hub people and the HydroShare team. So John Goodall's group is working on getting the Summa code available, and with the Quasi platform, where we've got some level of control, there are options available. So if I was to go back here and try go into, it's probably going to, I don't know if it's going to give me the choice of those, it's not going to give me the choice of kernels because I've got one running already. But there are, on some of the choices that we saw, things like LandLab, which is pre-installed, other instructions that are pre-installed, other packages that are pre-installed. So if it's something that's commonly available or perhaps commonly used in the hydrology community, then you could work with Quasi to have it installed. There's always a danger that as things evolve, the notebooks may or may not work, and Christina's pointing that out in some of the chat. She wrote a paper, and then the version of LandLab, I understand it was updated on the Quasi platform. So the code that was described in that paper didn't work on the new platform. So really, if you want your work to be reproducible, you sort of have to take ownership of the dependencies and document them as best you can. And that might involve installing it or including the code in a HydroShare resource so that it goes along as well. So what are the other things that, so Christina asked where the instructions I'm sharing. They are in this HydroLearn module.
Oh, I think she shared the link above.
Okay, Jenny put that in. Generally, will it be safe to assume students know Python? No. You have to go with whatever language your students know, and I guess you can with Jupyter work with Python and R. There is also a MATLAB option. So Quasi is supporting MATLAB as Jupyter notebooks can also work with MATLAB, and you require some sort of a licensing arrangement with MATLAB that Quasi has negotiated. So, but challenging, but yeah, the language for students to know is always a challenge, and you have to provide guidance on the basics often, depending on at the level that you're giving the instruction. Okay. So Christina's added some information. She's working actively with Jupyter Notebooks as well. Other questions? Okay, I better get off the screen here because
so I just wanted to add one for people who have their own notebooks in their own environments, and they're hopefully by August we'll have really clear instructions on how to add your own kernel without having to host an entire Jupyter hub. But or maybe even next week, in a week or so, we'll make it easier. But it does require some management and ownership since the environments are always changing.
Great. Well, thanks, Dave. Thanks all for all that feedback and questions. We're now going to move into the partner work time. So in this time, the team is asking that you review the alignment of your instructional content to your learning activities, revise to try to make better alignment, and as time allows, just continue to build out the rest of your content. So I think Jenny's probably, or Melissa, are going to send you your work areas unless anyone has any other questions. All right. Thank you so much. See you all this afternoon.